Okay, hello and welcome back to Dev Theory. Today I'm going to do something that...
That just makes me feel over the moon.
What? No. Really? Can I actually... Oh, this is annoying. Okay. Well, I tried to start this simple, but I guess that didn't want to work. Anyway, today I'm going to make a video for the average person who doesn't understand the components of a computer and how they relate to each other. So, why am I making this video? Well, because when I asked for what type of RAM someone had, they sent me something called 16 kilobits, and I have no idea what they sent me, to be honest. So I figured it might be important if there is a video on the internet that explains how you go about getting the actual parts of a computer, figuring out what you need to look for. So you have two different things. You have gaming and working. And it depends on what you're doing on the computer as to what you're going to buy. So for gaming, you don't really need... You need to focus more on what's known as a GPU, more than a CPU. A CPU is important, but a GPU is more important. A GPU is a graphical processing unit. A CPU is a computational processing unit? I think that's what it's called. I forget because I use the acronyms all the time. In other words, GPU is used for what you're looking at. CPU is figuring out in what order should things be retrieved, written, and received via the monitor. Basically, it is it's not the brain, because a lot of people compare it to the brain, but the CPU is the neural network the brain works with. So it's the synapses that allow it to work. The brain is technically the motherboard, because without the motherboard, the thing just doesn't work. So, the CPU is for, well, if you want to have multiple tabs open, if you want to have your Excel sheet open at the same time you want your Google Chrome open. That is your CPU. What displays it is what's known as your GPU. So therefore, if you are a gamer and you want to focus solely on gaming, then you mostly want to focus on GPU, and you don't need the best CPU, but you need a CPU that doesn't bottleneck, which is to say that the data that flows to the GPU doesn't want to be restricted. So you need something like a 4-core or 6-core machine at the time of making this video. I don't think 6 cores exist right now. Maybe on Intel, because they're a little woohoo. But mostly it's 4-core. And mostly you just want to focus on 2.5 gigahertz and above, because that usually doesn't bottleneck anything. So, what determines what motherboard you're going to get is your CPU. So I'm going to go to... I'm not paid by Newegg, by the way. I just know that Newegg has what I need in terms of what I'm looking for. Components, CPUs, and processors. Okay. So, first choice is whether you want to go rich or cheap. That's pretty much what the difference between these two are. Occasionally, AMD does better than Intel, and Intel does better than Ryzen. Intel's really good at gaming, Ryzen's really good at multi-threaded process, and mostly good at gaming. The reason being is okay, I gotta break down cores and threads. So imagine if you have a board and you have, let's say we have a 4-core machine. On that board, that means you have 4 separate dies. Okay, technically it's all one big die, but it's really 4 separate dies that interwork with each other. These are called cores. Now those cores can do a number of jobs. On a multi-threaded machine, each core is given a thread. Essentially, a thread is the ability to have one thought at a time. And by time, I mean somewhere around like deciseconds. So, most cores are dual thread right now. I don't think any of them go past 2 threads. So, if you have a 4-core machine, that means it has 8 threads right now, and that means it's capable of having 8 different thoughts going on in a decisecond, which is how your computer is able to seem like it's all happening at once, is because it's way faster at processing than us. So I'm going to go with AMD. These names are just the generation. You can look up what the newest generation is, and that, I mean, anybody can do that. But let's go here and see, like, Ryzen. You know what? Let's actually go to the past and look at FX, because many people have FX still. Because FX is still a good processor, and it's rather cheap. So, if you want an FX processor, you can get it for, like, $197, apparently. Alright, so, as I was saying, you've got a 8-core machine here. That means it has 8 cores and 16 threads. Let's click on this one. Okay? Now, what do these numbers mean? Well, believe it or not, the first number, this is the way that AMD works. The first number is how many cores there are. The second number is the generation. And usually the speed at which they default work at. So in other words, this says it's 4 gigahertz. But if I go down, this tab is why I needed this. So this says it's 350, 4 gigahertz. The original version only worked at 3.5 gigahertz. So I think this is either a newer generation or overclocked. So now if I click on this one, it'll be 4-core. Yeah, see, quad, 4-core, because there's a 4. And this will be 6-core, because it's got a 6, right? Oh, I'm loading very slowly. Don't tell me I have to restart my network again. Comcast has been giving me issues. Okay, reload. There we go. That was faster. 6-core. See? That first number in the name is how many cores there are. So let's go down here. Okay? There's a few things you want to pay attention to on the processor in specifications. The first is operating frequency, otherwise known as how fast each core goes. Potentially. That's really just how quote-unquote powerful the machine is. The core name tells you what generation it's part of, and the socket is what determines what motherboards are compatible with your CPU. So for instance, for this one, we want to look for an AM3 Plus socket board. Okay? Now you might be thinking, well, what about the rest of this? You don't really need to pay attention to the rest of this except for the 95 watts, because if you really want to get like cheapest uh, the cheapest power supply unit you can, you need to add all your watts up, and then make sure that you've got double that amount. Okay, so the primary thing you want to pay attention to is how powerful each core is, how many cores you have, and what type of socket you're dealing with. Okay. The reason why you only need like a 4-core CPU in order to work with video games is because usually one is writing the information. That a game works on a game cycle. So you can think of that as an infinite loop. And that infinite loop runs on one core. Very rarely do developers utilize other cores. Like AAA industry stuff, they might use the other cores, but like indie developers, they usually only deal with the one core. So even though processing power has made fantastic leaps and bounds, what was I saying? Oh, great. ADHD kicked in. Even though processors have made leaps and bounds, how we make video games is still very similar to how they were made in like the 90s. It's just we got better tools to go along with it. So one core is usually used for processing most of the information, and then like a second core may be used to grab textures as they're loading in and things like that, but very rarely does it go beyond 4 cores. Now, on the other hand, what does use the cores is if you're trying to record a video at the same time you're playing a game, then you need another core. If you're trying to encode a video, usually encoders support multi-threaded CPUs because you are trying to put in information as fast as you can from multiple different sources, which means that one end of the video can be worked on while the beginning end can be worked on, and it's really how fast it is. By having more threads, you're able to compile the information faster, which is different than a game cycle because it's running on one loop. All the actions happen on one loop. So when you're dealing with multiple workloads, like for instance, I have Real VNC, Firefox, Twitch, Origin, OBS, Chrome, even Steam open, all those are right now they're running on different cores. They're running in the background, but they're running on different cores. So the more cores you have, the more applications you can have open to do your work. Various different reasons why you would want multiple cores. Okay, so now that we know we want an AM3, we have selected the CPU. Now there are 5 components in any computer ever. There is the CPU, the motherboard, the GPU, the RAM, and the storage. Okay? The CPU is what determines the motherboard. The motherboard determines what you're allowed to have on everything else. So now that we know we need an AM3 Plus motherboard, let's go back over here. Components, motherboards, specifically AMD motherboards. And we look over here and we get a CPU socket AM3 Plus. Apply. Alright, let's click on the first one here. Okay, so what does all that mean? Okay, well that is literally just the name. That confusing pile of letters right there is the name, and that's the brand. That Rev2 is the revision number, which means that there were problems in the first one and that they couldn't just like send out a BIOS update for. So this is the second revision. This tells us how many what type of processor it can support. This tells us the chipset it supports. The chipset is the brain. It's what allocates what to what devices, and it's usually directly on the board. And it's like that little heat sink on it might be it. The little weird looking claw thing over there might be it. I would actually have to look directly at the motherboard. Let's go ahead. So if I zoom in here, so here is where the RAM goes. This is the serial ATA processor. In other words, it's the thing that connects to your hard drive or SSD. Here's the MOS. This is the most important part, and I think this is the chipset right here. I might be wrong about that. I can't see the details. I don't know. It's somewhere on here. It's somewhere. The chipset, where the chipset is not really important. Just knowing the chipset is not really important for the average user. Knowing the chipset is more of a developer preference than it is anything else. This tells you the speed at which your hard drive or SSD can go. In other words, you need to find either a 3 gigabyte per second or a 6 gigabyte per second hard drive. It won't go past that. This ATX tells you the size. This is a standardization. This is a size of the motherboard. So you have micro ATX, ATX, and I forget the other ATXs because I don't deal with them. Okay, specifications. Now, specifications, what we're looking for here is the PCI bus and the memory standard. Okay, because those two will determine, the PCI bus will determine what graphics card you can buy, and okay, I should restate that. PCI is backwards compatible. So you can buy a new generation graphics card even though you have like a PCI 2 and it will still work. It won't work nearly as well on the new PCI because it was developed using the new PCI. So you want to pay attention to the PCI bus for the simple fact of you have 3 different PCI. And you want to make sure that your PCI fits in the previous PCI slots. Okay? So, first thing we're going to look at is memory standard. So, right here, you have the memory type, which is DDR3, and the memory speed. Okay? So, this is how fast it can go. Wait, no, hold on. No, I'm not looking at the RAM. Oh, wow, I made a horrible mistake. Okay, so this is the type. This whole thing is the type that it can take. So DDR3 to 2000 if it's overclocked. DDR3 1866. These numbers are just types of memory. This is the type of DRAM it uses. This is the standard it uses. Okay? And this is how many the board can support altogether. Because regardless of what Windows can support, because Windows 64-bit can support up to, I think, 512 gigabit now, the board can only run so much information over its own circuitry. So this board is capped at 32 gigabits. But this right here is the type, okay? And then we come down here and we look for the PCI bus. PCI, there it is. This is what I mean by PCI bus, okay? So they're really called expansion slots by most people, but I'm a developer. I refer to them as PCI bus. Each one of these is a different type of PCI slot, okay? And you need to make sure that your graphics card can fit into that PCI slot. That's pretty much it. Okay, so now we're gonna, let's see, what is this compatible with? So now that I know the memory standard, these are the types of RAM that I'm going to look for, okay? So we're gonna go to components, we're gonna go to memory, just click on memory, okay? And we are gonna desktop memory. Okay, so we're looking for DDR3. Okay. Okay. Now, I remember it saying 2000 OC. Maybe. Oh, yeah, yeah. It said this. I know that. I know that, and I don't know about that one. So we look for the memory standard, and then this gives us our RAM, pretty much. You just buy what the big number says. Mostly what the big number says. Beyond that, if you want to get into like specifics, you can get into timing, and timing is very important as to how fast the operations are going to go, because even though this is the maximum storage space, okay? So in other words, you can have 16 gigabytes of information inside of a RAM stick at one time. That doesn't necessarily tell you how fast it's going to go. This does. But most people don't need to pay attention to this. You just basically want these three numbers to be as low as possible. Okay? And then, like I said, the graphics card, you just want to look for video cards. Wait, I clicked on that, didn't I? Components, video cards, desktop graphics cards. Okay. So, primarily, you just want to look for the... let's just click on this one. You want to look for the PCI bus. It doesn't matter what brand you go. You want to look for the interface, as it's known as. I don't really know why it does that. And that pretty much tells you whether it's going to fit in your board or not. And I mean, there's hard drives, I suppose. But let's look at a hard drive. Okay. Desktop internal drives. Speed. This is how fast the disk. If you have a hard drive, this is how fast the disk is gonna run. And the faster a disk can run, the more information can be put in a disk and read from a disk. And then this is pretty much what you wanna filter out with, is which version you the motherboard supports. Okay, so since it said it was only SATA 6, we can go with this, and you'll get your SATA 6 hard drives. And really, that's it. I think I covered everything. That is all the components and what you actually need to pay attention to in order to build a computer. Now, you just need to put it together. Now, there are several guides on how to put it together, but actually finding out which parts you need to put the thing together, that I didn't find very many videos of that, because uh, although, like I said, when I was talking about the processor, the naming the naming scheme that AMD uses is different than what Intel uses, but you can find out how many cores it has and how strong each core is and what type of slot you're looking for, and you just look for that type of slot. I mean, it's just really a modification of what exactly it is. Excuse me, where exactly it is, because they decided, oh, we're gonna be fancy and put it somewhere else. Um, that's pretty much it, though. That is exactly how you find the parts right now, as of this date, uh, for a computer. That's how you buy parts for a computer, to the best of my knowledge. Uh, yeah, okay, I think we're done here. See you later.